project that's about electronic waste and circuits. My name is Sebastián Quiñones Arzú.
My name is Oscar de la Rosa Lopez.
My name is Moises Martín Villalobos Ramirez. Okay, we will talk about e-waste in Mexico. That is the main problematic about this situation. That is that within 1.4 million metric tons of electronic waste produced annually in Mexico and increasing. Unfortunately, just 10% of that amount of electronic waste is actually being recycled, and the other 90% is unfortunately a risk, an actual risk for the environment. Well, why we need to solve this? Because this is really important for an SDG, a social development goal. In this case, the number 12, that is the responsible consumption and production. And this is really important for our country because if we don't have control of our consumptions, we will eventually end up running out of things to consume. So now we will talk about the solution and how it will work, this possible solution.
So the possible solution we're proposing is the Winston Bridge, which instead of buying new resistors, you can actually reuse salvaged ones. By testing the salvaged resistors, by measuring the resistance of the old resistors or the unknown resistor, we can find the actual value of it. And we can ensure the quality of the resistance being salvaged, which can be used later on for another circuit and reuse the resistor instead of buying new ones and creating even more electronic waste.
This has its obvious advantages and disadvantages. But first, with the pros, is that it is very precise because since we will explain later how it works, but it is very precise and can measure physical parameters such as temperature, light, and strain. It not only works with just resistors and can work with other ways. It also can work with impedance, inductance, and capacitance. And this Western Bridge has many variations that can be useful for other types of project. However, we have the cons. If the resistance that you want to measure are extremely low, the resistance let's become very insignificant, the changes, so it can make very not trustworthy results. On the other hand, if it is a very high resistance measurement, it makes a very insensitive to balance, and the result may not be so accurate. There is also this problem that if the current is very high, it can permanently damage the resistance. So how exactly does it work? Well, as you can see on the diagram, it works by putting a battery, three resistance, and one, well, the test resistance, the one we are going to salvage and see, does it work or not? Then this is connected to a terminal A and to terminal B. If terminal A is the same as B, it means it works. But what happens if it is lower than Rx? Well, the bridge becomes unbalanced. We now can see that this resistor really doesn't work like I want. Terminal A becomes higher than terminal B in voltage, and it is changed in terminal B becomes higher than A if the value is higher than Rx. So what happens if value is equal to zero? Well, it just means that there is no resistance, and if there is no resistance, all the voltage is going freely across A and B, meaning that that is not useful. But if it is infinite, that means that it is a lot of resistance, making that not too useful again. It is basically a piece of plastic or too much resistance.
So what happens if the circuit is balanced? That would mean that terminal A has the same voltage at terminal B, meaning the resistors. That would tell us that the resistance being tested is can be used. So how does it work? A total of four resistances, R1 and R2, which are known resistances, and they will be forming the left leg, and then R3 and the R tested, which is one known and the unknown on the other leg. And there's also a voltage source that provides power to the whole bridge, and the circuit operation operates by comparing the voltage drop going across R1 to R2 and from R3 to the R tested. The principle is simple math and it's a proportion where R1 is over R2 and R3 is over the R tested.
Okay, well, personally, as an individual conclusion, I would like to tell that this problem situation helped me too much to develop my abilities as a future mechatronic engineer. It really helped me too much to understand all this stuff, not only in the theoretical part, also in the practical part. And even when we weren't able to really uh, plot all this stuff in a physical way, I think that I understand a lot of this and it will be really useful for me in my career.
So my conclusion was actually that I liked it due because it was way of practicing something that can help the environment, which I didn't even know that would harm it so much. And also, I also enjoyed the part of the project where we got to play with LTS spice and actually got to testing if the resistance what would happen if the resistance would have different values, and I found that very interesting.
Especially because recycling should be a last resort, because the moment you destroy something to make another, it also leaves some residue. Because, like I said before, reusing should be the priority. Thanks.
Thank you very much.
Thanks.